Precalc, this is 1.5. We're talking about equations. So, an equation, guys, I already listed it for you, so you don't have to write it down if you have them printed. It's just a statement of two mathematical expressions that are equal. Yes, it's expressions, algebraic expressions that are linked with an equal sign. That's what makes it an equation versus an expression. So obviously an example would be 2x plus 3 equals 4x minus 8. You guys should be able to solve that. Whether it comes to a nice number or not, that's an equation now. Now remember, equations come with many different variables in it. As we get going, the more variables you have, different variables you have, the more equations you need, correct? Two variables means you need to have two equations and so forth. What's a solution then? We sometimes call them the roots of a problem. Solutions, roots. Well, they're just solutions. How about the value of the variable that makes it true? So it's the value of the variable that would make it so that the expression is true, or the equation is true. So in the top equation, it's what? 11 divided by 2, so 5.5. So the solution to the top equation is 5.5. It's because when I put 5.5 into both sides, I get the same answer. Two equations, guys, with exactly the same solutions, or solution, are called something. We generally don't use this a lot. The book highlights it as a definition. This column, if there's the same solutions, that means they are equivalent equations. So there's called equivalent equations. So just be careful how they word their problems. They may throw that in there and say, solve these equivalent equations, which means they should have the same equation. I quickly put on there the properties of equality. If A is to equal B, well then A plus C would be B plus C. Adding the same quantity or subtracting, we can say the same quantity to both sides gives you an equivalent equation. Same thing goes for multiplying and dividing, right? Now I'm saying multiplying and dividing even though it only has multiplication on there in part 2, just like I said subtraction for part 1, is because you can take every division problem, bless you, and turn it into a multiplication problem by multiplying by a reciprocal, yes? So therefore they are the same thing. Multiply both sides of an equation, it doesn't change it. So AKA on the bottom, also known as what you do to one side, you have to do to the other. Yes, this is very much Algebra 1 style there, right? As in basic math stuff here. And if you don't, for some reason, accept or know this, the rest of the year is going to be a little tough for you. Okay? Any questions? So, obviously, going to that first example that I had given you, can you solve those? I'll give you guys a couple seconds. We'll go over it. And I also said check it. If you guys want to move on from just simply getting a B plus A and you want to get to A plus, you better do the check it side. You better show me that you, first of all, can get to the solution by showing me your work. But you also need to plug it in, check it, so you can tell me, yes, Mr. Konchak, I am correct, I am right, or no, Mr. Konchak, I was wrong, I'm going to go back and fix it. Have some perseverance in there. So when I wanted to solve this, remember, when we're solving a linear first degree equation, or anytime we're trying to gather up like terms on the same side, remember what you do to one side, you have to do to the other. And it really doesn't matter. I can bring 7x to the right or 3x to the left, but which one is probably the better choice? 3x. Why would we move 3x instead of 7x? Positive. Yes. If I move the smaller variable, the one with the smaller coefficient, I am more likely to have a positive result at the end. And I'd rather work with positive people and positive numbers than negative things. And so, very quickly, subtract 3x to get 4x minus 4 equals 8. Add 4, 4x equals 12. And the very last step is divide by 4. We have done this over the course of the last several years lots and lots of times. Yes? That's Algebra 1, if not pre-algebra. You've done that many times. And then we've done that every year since. The biggest thing is, great, you found it, you showed all of your work, that's great. That'll get you that 5, possibly into the 6 range by showing me like stuff like that. But if you want to get to the 6 to the 7, which we'll talk about that grading scale later, and some of you guys know about that, is you need to check it. And what's the whole process about checking your problems again? There are some things you can do and some things you can't do. What should you do? You guys all know how to do this. Put x back into, the value of x, right? The solution back in for x in the original equation. And notice I will be using parentheses. And the reason is because that way I don't lose any negative signs someplace that might be on my solution. Am I allowed to move across the wall this time, or that equal sign? No. We're going to act like the equal sign again, in this case, is a wall that you can't cross, but at the end, you can kind of peer over the top and say, what are you? And so together, they look over the wall and say, hey, we're the same. 7 times 3 equals 9 plus 8, and they look over the wall and they see each other, so then therefore they say, good to go. That's what I want to see. If you wanted to get the full credit that would be available for this problem, if this was on your quiz, this is what you would need to show. Are there ways to improve that? Sure. You could go in and tell me what properties you want to use in here. There's always things you could do. But that is pretty nice right here. Sometimes, like the second example on the bottom there, it's just a bunch of variables. Now this one very well could have been lifted from your geotrig book. So as I was saying, we could probably see that this would have maybe came from my geotrig book on the abstract expressions or algebra section of it, where they took all the numbers out of an equation and then they threw a whole bunch of variables in, and then they asked us to solve for one particular variable. Granted, this one is f equals g times the fraction of little m times big M all over r squared. It wants us to solve for the big M. So this one is using all of those rules of equality, solving for something arbitrarily like a variable. Doesn't matter if I'm talking about a variable or talking about a number or anything else. Things will be used the same. If they were multiplied in the beginning, you can divide them out. If they're added, you subtract them. You undo by doing the opposite or inverse operation. So, big M is there. How can we modify this to maybe make this move in one move? Because that's another thing about people who are more efficient should get a better grade, as in they know more about math. I'm not saying that you could do this in about 1, 2, 3 steps, but you actually can probably do this in 1 or 2 steps. How can I create just one fraction? It's g times the fraction. Will? You're going to say something?
Could you just like multiply the whole thing by r squared?
We could do that. We're going to go through a couple of steps. Would everybody be okay if I said r squared to both sides, yes? So now I have r squared f, that's a big F, should be big F, equals what? G m m. Last step. Max?
Divide both sides by g little f.
Yes. G little m, G little m, and so m equals r squared f over g little m. And you're done. It's a little harder to check your answer on these ones. Now, what if I said that we actually could have done this possibly in one step? Because, what if I said that automatically that would have been over 1 anyways, right? That means the g should go to the what? G would actually be on top. And so, instead of multiplying by r squared and then dividing by g little m, couldn't I just multiply everything by the reciprocal? So I could have done all of that in one step. A little bit more elegant, a little bit better, but they both give us the same answer. Both are going to get you the credit. Okay? Next type of problem that you're going to come across is when you're given a formula, like the surface area of a rectangular box. Hopefully people recognize that. Solve for w in terms of the other variables. So now we do have some numbers, but now there's more than just multiplying and dividing. We got some addition and subtraction going on. Want you to solve for w. This one's a little bit trickier because w is in 2 of those terms. It's not on all 3. Because you've got to get w by itself. So what's an option here? What can we do? Yeah. That sounds like a good plan to me. Move the 2LH to the other side by subtracting a 2LH. Minus 2LH. So I just rewrote it. What would be the next good step to do? Yeah, Lizzie. Factor out a W. Yeah, guys, take the W that's in the 2 items that are there and take it out. So 2L plus 2H equals A minus 2LH. And last step. Max?
Divide 2L plus 2H.
Yeah, divide both sides by 2L plus 2H. So all of that cancels without having to rewrite it for now, just to save a little bit of time. There is your answer. We start to kick it up, go to second degree, quadratics. Obviously, we have a quadratic equation of ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot be 0, because if a was 0, then you have a first degree problem, and that's a line. So, what we do on these is we factor them. This is the first thing we'll do. And we need to know this real product property that says that if I have 2 numbers multiplied together to equal 0, that means if and only if a equals 0 or b equals 0. So, we take the quadratic, we break it down to its factors. The factors are multiplied. That means we can set each factor equal to 0, and we can solve them individually. Again, things you've done thousands of times. So, how do we factor that? A is equal to 1. Oh, I can't do this yet. Why not? Yeah, Guys, the only way you can solve a quadratic is if it's set equal to 0. So I actually need to subtract 24 over to get x squared plus 5x minus 24 equals 0. It has to be set equal to 0. Can't stress that enough. Now, a is equal to 1, so therefore, all I need to do is say, what are the factors of 24 that add up to 5? I like 8, I like 3. Has to be a positive 8 and a negative 3. And guys, this still equals 0. That is the zero product property going to be used now. That means x plus 8 equals 0. It also means x minus 3 equals 0. Or x equals negative 8 and 3. If I check this, I have to check it really how many times? Twice. I'll check one, you guys can check the other on your own time. Going back to the original problem, let's do negative 8 squared plus 5 times negative 8. And that should equal 24, correct? What's negative 8 squared? 64. I'm glad I did not hear negative 64. That means people are not using their calculators. Some people put that in their calculator and get a negative 64. How did that happen? What did they forget to use? Parentheses. Of course, your calculator is going to do order of operations, power first, and then multiply by negative 1. So be careful. And 5 times negative 8. So negative 40. That should equal 24. And does it? 24 equals 24. Check mark. We're good to go. I think some of the easiest quadratics to solve are the ones they call simple quadratics, where it's just something squared equaling a number. So all you have to do to get rid of the square is take the square root. But don't forget, one side you do the other, but when you're taking a square root, solving for a variable, you need to have plus or minus. And that's what it states up here, is that it's the positive square root of c and the negative square root of c for the same x. So when I go to square root, I always like to just tuck in right in front. It's kind of hard to see on top of my equal sign there, but I do put plus or minus the square root of 5. So x equals plus or minus the square root of 5. You check it by square root of 5 times square root of 5. 5. A negative square root of 5 times negative square root of 5. 5. Good to go. Part B, they try to trick you a little bit. Yeah?
Should we show that?
Show the checking, you mean?
Yeah.
You always should show. I mean, the time that I wouldn't show checking is if the bell's going to ring in 5 minutes and I still have a problem to do. So maybe if you haven't shown the checking already and you still have to work to do, then kind of leave that for the end. But if it's something simple like this, you know, it takes 3 seconds longer, then maybe you might want to do that. The next one, they try kicking it up a little bit, but it's the exact same setup. But when I go to square root both sides, adding my plus or minus, the square and the square root cancel each other. That makes sense. We've done that before. Just remember the whole inside is equal to plus or minus the square root of 5. And then we do what? Add 4 to both sides. Get used to the idea of making sure you say that. Now, does that mean it's plus or minus the square root of 9? No. Now, as I tell my other students, the younger ones, the one number that you're moving over, in the 4 in this case, always put it in front. How many answers do we have? 2. There are 2 answers. And so make sure you understand Now, if I asked you for the exact solutions, this is it. You leave it right here. 4 plus or minus the square root of 5. If I ask for decimals, then you have to break it. You have to say, okay, one of these is 4 plus the square root of 5, and the other one is 4 minus the square root of 5. Take your calculator out and figure it out. But those are the two answers. But if I'm just looking for real solutions and I'm not looking for decimals, I want you to leave it there. Day 1 homework on page 57 from 1.5 is 1 through 21 odds. Have a great day.